Early morning, Washington, D.C., and a young woman is trapped in a burning tower. At the Washington Fire Department a few kilometers away, the firefighters respond to the call. It's only a drill, but they're taking it deadly seriously, and every second counts. It's vital they can depend on a fire engine which will start reliably every time, get them to the scene quickly, and do its job when it gets there. It's literally a matter of life and death. Fire engines today are sophisticated, high-tech machines. They have to be personnel carriers, toolboxes, and aerial platforms rolled into one. So, how do engineers create the ultimate tool for firefighting? Since 9/11, the fire department of the United States Capitol has been on high alert. The firefighters go about their daily job expecting the worst.
Being a DC firefighter, we can deal with just about anything from a sick person to a house fire, as far up to a major building fire to a terrorist attack here in the city. We can find ourselves in situations where we don't make it home, so we put a lot of emphasis on these fire engines to make sure that they work.
The fire engines they depend on are made here, in Clintonville, Wisconsin, the fire engine capital of the USA. Clintonville is home to Seagrave, the company responsible for building America's fire engines since 1881. The Seagrave fire engine has come a long way. It still has an engine, ladder and pump, but those are the only similarities between these old engines and today's state-of-the-art machines.
Talk to the people that actually use our fire trucks, and the way they talk, this is the only truck built. There's nothing better.
So how does Seagrave build the ultimate fire engine so it's up to the toughest firefighting challenge? The first thing a fire engine needs is speed. But what sort of engine is capable of giving a hulking great 30-ton truck massive acceleration and a high top speed? The answer is this awe-inspiring 13-litre, 525-horsepower Caterpillar engine. The engine itself is almost as big as a car, and it needs to be. It has to haul over 30 tons at over 100 kilometers an hour, and what's more, it has to start first time, every time.
This is an industrial strength motor. It's not like you put in your normal pickups or nothing. This thing's made to take her and it's made to last.
Once the engine is finished, it's lowered into position on the axle, which is then wheeled away for the other components to be added. At the drill, the engine has done its job and delivered the firefighters promptly to the fire. Now it assumes a different role, to power the massive water pump on board. At each fire, explosions, crumbling buildings and falling masonry add to the risks for firefighters. On 9/11, 36 firefighters are said to have been saved from death inside their cabs as the Twin Towers fell around them. So what's the secret of the cab's strength? The skeleton of the cab is a virtually indestructible frame of interlocking steel tubes. Its panels, though, are made of aluminium to reduce weight. The aluminium is cut on this $1 million laser machine that slices the frame to within a millionth of an inch.
This is the most advanced laser of its kind. We want to make the best cuts to make the best trucks.
The cab's steel tubes and aluminium panels are interlocked to create an incredibly robust subframe. The cabs are then lowered onto the chassis and on-board equipment installed. Fans, computers, storage. Back at the fire, the operation is underway, but the woman is still trapped. Lives depend on the ladders that each fire engine carries. These ladders are marvels of engineering in their own right. They've got to be light and long, extending to over 100 feet without causing the fire engine to topple over. But they've also got to be strong enough to cope with the weight of several people at a time, and even to be used as a battering ram, capable of smashing through walls or knocking in windows. Each ladder takes 5 weeks to build. The ladder starts off life as steel coil. Steel keeps its strength in high temperatures. Once the side panels are made, holes for the steel rungs are punched in. The rungs are strengthened with K-brackets, which allow each ladder to carry 230 kilograms at its tip. At the fire drill, the ladder is extended 3 stories up to rescue the woman from the burning tower block. Another life saved.
It's a real great job to have, knowing that you're building something that can save somebody's life someday.
Firefighters have to be ready for action 24 hours a day, 7 days a week. And so do their fire engines.